Right, let's take a look at target 32. Identify polynomials and state the degree. In this question, you're asked to circle the ones that are polynomials, and if yes, give the degree. In looking at this, you guys, the whole idea in figuring out if something is a polynomial or not is based on the idea of what is it going to look like when you graph it. Remember, polynomials typically look like some kind of a roller coaster pattern or some kind of smooth curve that kind of keeps going. If you were to look at this first one, we know that that's an x squared, another x squared, and an x in it. That's just going to kind of parabola there. So therefore, yes, this is going to be a polynomial. And the degree for that would be 2. The degree comes from the highest power when they're written as a sum. If you look at the next one over here, well, I've got an x squared kind of a situation, another x squared situation. But the problem is this is not written as a sum. This is written in factored form. So if I were to actually go through and multiply this out, I'm going to get a long string of numbers and letters. It's going to look like this if I multiplied that out. And therefore, I need to multiply. So I'd have an x squared here and an x squared here, and then eventually that would give me a 4th power polynomial. And yes, this is a polynomial. Next one, x squared plus 2 to the x. This is not a polynomial because you have an x power. The definition of a polynomial is when you have any number you want. Could be a decimal, fraction, whatever, and then if you take it times x, it's got to be to some whole number power up here. You have to have a whole number. You can't have any decimals up here, you can't have any fractions, or you can't have any, so it's got to be a whole number. Well, if the power was x, then I could make up any number I want, and that's going to, like I could put a decimal in there then. Well, that's going to no longer make it qualify to this because it wouldn't be a whole number up there. Okay, next, a line, 3x minus 1 would graph as a line. Yes, that's a polynomial because anytime you have x, that's like having an x to the 1st power. So that would work. It'd be a 1st degree polynomial. This here would be a 2nd degree polynomial. That's going to work. This one would not be a polynomial because it has an x squared and a y squared in it. Therefore, it's going to make something along the lines of a circle or an ellipse kind of a shape. So that's not going to be continuous. This one is not a polynomial because it has an x squared in the denominator. So this would be a no as well. This one over here would be, that's an x to the 1st power kind of equation. So yes, that would work. This one would also work. And a plain old number also works because that's the same thing as having -7 times x to the 0th power, because any number or any letter or any number to the 0 power is 1. So that's the same thing as -7 times 1 or just -7. This part right there equals 1. So those are the basics of polynomials, and that's what they look like. They look like those long string of numbers and letters, whether they're added together or being multiplied together, but what you're looking for is whole number exponents. The exponents are the key to make that determination.